Welcome to our deep dive into the fascinating world of prisms in physics. Today, we'll explore how these simple geometric objects can unlock the mysteries of light. Prisms have been used for centuries to study the behavior of light, revealing everything from the colors of the rainbow to the fundamental principles of optics. Whether you're a student, a science enthusiast, or just curious about how light works, this journey will illuminate the science behind prisms and their role in our understanding of the physical world. Let's begin by understanding what a prism actually is and why it's so important in physics. Prism is a transparent optical element with flat, polished surfaces that refract light. Typically made from glass or plastic, prisms are shaped like a triangular block. When light enters a prism, it bends or refracts due to the change in speed as it moves from air into the denser material. This bending of light is what makes prisms so useful in scientific experiments and optical devices. Prisms are not only found in laboratories but also in everyday objects like cameras and binoculars. Understanding their structure is the first step in appreciating their scientific significance. Study of prisms dates back to ancient times, but it was Isaac Newton in the 17th century who truly unlocked their secrets. Newton used a glass prism to show that white light is actually made up of many colors. His experiments laid the foundation for modern optics and changed our understanding of light forever. Today, prisms are still used in scientific research, classrooms, and even art installation. Their ability to split and bend light continues to inspire curiosity and innovation in the world of physics. Typical prism has two triangular bases and three rectangular sides. The angle between the two bases is called the apex angle. The material of the prism, usually glass, determines how much the light will bend as it passes through. The smooth, flat surfaces are carefully polished to ensure that light can enter and exit without scattering. This precise construction is crucial for experiments that require accurate measurements of light refraction and dispersion. A beam of light strikes the surface of a prism. It slows down and bends due to the change in medium from air to glass. This process is known as refraction. The amount of bending depends on the angle at which the light enters and the refractive index of the prism material. As the light continues through the prism, it may bend again when exiting, depending on the shape and orientation of the prism. This bending is the key to many of the optical effects we observe. Fraction is the bending of light as it passes from one medium to another with a different density. In the case of a prism, light travels from air into glass, which is denser. This causes the light to slow down and change direction. The degree of refraction depends on the wavelength of the light and the refractive index of the material. Shorter wavelengths like blue and violet bend more than longer wavelengths like red. This difference is what leads to the separation of colors. One of the most fascinating effects of a prism is its ability to disperse white light into its component colors. This phenomenon, known as dispersion, occurs because different colors of light bend by different amounts as they pass through the prism. The result is a beautiful spectrum of colors, just like a rainbow. Dispersion is not only visually stunning but also scientifically important, helping us understand the composition of light and the nature of color. When white light passes through a prism, it spreads out into a band of colors known as the visible spectrum. This spectrum includes red, orange, yellow, green, blue, indigo, and violet. Each color corresponds to a different wavelength of light. The visible spectrum is just a small part of the electromagnetic spectrum, but it's the part that our eyes can see. Prisms make this hidden world of color visible and tangible. Separation of colors in a prism happens because each color of light travels at a slightly different speed in glass. This causes each color to bend by a different amount. Red light bends the least, while violet bends the most. This difference in bending is called angular dispersion. It's the reason we see a spread of colors instead of just a single beam of light coming out of the prism. Prisms are more than just classroom tools. They play a vital role in scientific research. In laboratories, prisms are used to analyze the composition of light from stars, helping astronomers learn about the universe. Chemists use prisms and spectrometers to identify substances based on the light they emit or absorb. Even in medicine, prisms help in the design of optical instruments that diagnose and treat diseases. Their versatility makes them indispensable in many fields. You might be surprised to learn that prisms are all around us. They're used in cameras to direct light onto sensors, in binoculars to flip images right side up, and even in some eyeglasses to correct vision problems. The principles of refraction and dispersion that make prisms so useful in science also have practical applications in technology and daily life. Next time you use a camera or look through binoculars, remember the humble prism at work inside. Isaac Newton's famous experiment with a prism changed the way we understand light. By passing sunlight through a small hole and then through a glass prism, Newton observed that the light spread out into a spectrum of colors. He realized that white light is actually a mixture of all the colors of the rainbow. This discovery was a turning point in the history of physics and laid the groundwork for the field of optics. Angle at which light enters and exits a prism is crucial to how much it bends. This is known as the angle of incidence and the angle of emergence. By carefully measuring these angles, scientists can calculate the refractive index of the prism material. This information is essential for designing optical instruments and understanding how light behaves in different environments. Sometimes, when light hits the boundary inside a prism at a certain angle, it doesn't exit but instead reflects entirely within the prism. This is called total internal reflection. It's the principle behind fiber optics and many optical devices. Prisms that use total internal reflection can redirect light with almost no loss, making them extremely efficient for guiding light in technology and communication systems. There are many different types of prisms, each designed for specific purposes. The most common is the triangular prism, but there are also rectangular, pentagonal, and even specialized prisms like the Dove prism and the Porro prism. Each type manipulates light in unique ways, making them suitable for different scientific and technological applications. Triangular prism is the classic shape most people think of when they hear the word prism. It has two triangular bases and three rectangular sides. This shape is ideal for splitting light into its component colors, making it a staple in physics experiments and educational demonstrations. Its simple geometry makes it easy to understand and use. Rectangular prisms are often used in optical devices where the goal is to redirect light without splitting it into colors. Their parallel sides allow light to pass through with minimal dispersion. These prisms are commonly found in cameras, projectors, and other imaging equipment, where controlling the path of light is more important than separating colors. Dove prism is a special type of prism used to invert images. When light passes through a dove prism, the image is flipped upside down. This property is useful in optical instruments that require image rotation, such as telescopes and microscopes. The unique design of the dove prism makes it a valuable tool in scientific imaging. Porro prisms are widely used in binoculars to flip and reverse images, making them appear right side up and correctly oriented. This clever use of total internal reflection allows for compact and efficient optical designs. Porro prisms are a great example of how physics principles are applied to solve real-world problems in technology. Spectroscopy is the study of how light interacts with matter, and prisms play a key role in this field. By splitting light into its spectrum, prisms allow scientists to analyze the composition of stars, chemicals, and even distant galaxies. Spectroscopy has led to countless discoveries, from identifying elements in the sun to detecting exoplanets. Modern communication systems rely on the principles of light and optics, and prisms are an essential part of this technology. Fiber optic cables, which transmit data as pulses of light, use prisms and total internal reflection to guide signals over long distances with minimal loss. This technology powers the internet, phone networks, and even medical imaging devices. Beyond science and technology, prisms have inspired artists and designers for centuries. The way prisms split and scatter light has been used in paintings, sculptures, and even architecture. The interplay of light and color created by prisms adds beauty and intrigue to artistic works, showing that physics can be both practical and inspiring. Nature itself uses the principles of prisms to create stunning visual effects. Rainbows, for example, are formed when sunlight passes through raindrops, which act like tiny prisms. The light is refracted, dispersed, and reflected inside the drops, creating the colorful arcs we see in the sky. This natural phenomenon is a beautiful demonstration of the physics of prisms at work. Prisms are a staple in physics classrooms around the world. Teachers use them to demonstrate the properties of light, refraction, and color. Simple experiments with prisms can make abstract concepts tangible and engaging for students. By observing how light behaves in a prism, learners gain a deeper appreciation for the science behind everyday phenomena. Our perception of color is directly linked to the way prisms separate light. When light is split into its spectrum, each color stimulates our eyes differently. This is why we see a rainbow of colors instead of just white light. Understanding how prisms affect color perception helps scientists develop better lighting, display technologies, and even art materials. Many optical instruments rely on prisms to function. Microscopes, telescopes, and cameras all use prisms to direct, split, or combine light. The precise control of light paths provided by prisms allows these devices to produce clear, accurate images. Without prisms, much of modern science and technology would not be possible. Some prisms are designed to polarize light, meaning they filter light waves so that they vibrate in only one direction. Polarizing prisms are used in photography, LCD screens, and scientific instruments. By controlling the polarization of light, these prisms enhance image quality and reduce glare, making them valuable in both science and everyday life. Lasers are another area where prisms play a crucial role. Prisms can be used to steer, split, or combine laser beams in scientific and industrial applications. Their ability to precisely control the direction and properties of light makes them indispensable in laser optics, from medical devices to manufacturing equipment. Photography, prisms are used to direct light onto camera sensors and to create special effects. Some cameras use pentaprisms to provide a correct, upright view through the viewfinder. Prisms can also be used to create artistic effects, such as splitting an image into multiple colors or shapes. Their versatility makes them a favorite tool for creative photographers. Binoculars rely on prisms to provide a clear, correctly oriented image. By using Porro or roof prisms, binoculars can flip and reverse the image so that it appears right side up and not mirrored. This clever use of optics makes binoculars compact, lightweight, and easy to use for everything from birdwatching to stargazing. Fiber optic technology uses the principles of total internal reflection, often achieved with prisms, to transmit light signals over long distances. This technology forms the backbone of modern communication networks, enabling high-speed internet, phone calls, and even medical imaging. Prisms ensure that light signals travel efficiently with minimal loss. Holography, the science of creating three-dimensional images, often uses prisms to split and direct laser beams. By carefully controlling the path of light, prisms help create the interference patterns needed for holograms. This technology is used in security, art, and data storage, showcasing the versatility of prisms in cutting-edge science. Astronomers use prisms to analyze the light from stars and galaxies. By splitting starlight into its spectrum, they can determine the chemical composition, temperature, and movement of celestial objects. This information helps us understand the universe and our place within it. Prisms are thus essential tools in the quest to explore the cosmos. In chemistry, prisms are used in spectrometers to identify elements and compounds. By analyzing the light emitted or absorbed by a substance, scientists can determine its composition. This technique is vital for research, quality control, and even forensic investigations. Prisms make it possible to unlock the secrets hidden in light. Medical devices often use prisms to direct and manipulate light for imaging and diagnostics. Endoscopes, for example, use prisms to provide clear views inside the human body. Optical coherence tomography, a technique for imaging tissues, also relies on prisms. These applications highlight the importance of prisms in advancing healthcare technology. Security systems use prisms in devices like periscopes and surveillance cameras to redirect and split light. This allows for better coverage and more effective monitoring. The ability to control light paths with precision makes prisms valuable in designing secure environments, from banks to research labs. Entertainment technology such as projectors and stage lighting often uses prisms to create dazzling visual effects. By splitting and combining beams of light, prisms can produce vibrant colors and dynamic patterns. This adds excitement and creativity to concerts, theater productions, and multimedia shows. Some eyeglasses use prisms to correct vision problems like double vision or eye alignment issues. By bending light in specific ways, these lenses help the eyes focus properly. This application of prism physics improves quality of life for many people, demonstrating the practical benefits of optical science. Navigation instruments such as sextants and compasses use prisms to reflect and direct light for accurate readings. These tools have guided explorers, sailors, and pilots for centuries. The reliability and precision of prisms make them indispensable in navigation and exploration. Prisms are used in photometers and other instruments to measure the intensity and properties of light. By splitting light into its spectrum, these devices can analyze everything from sunlight to artificial lighting. Accurate light measurement is essential in fields like environmental science, engineering, and manufacturing. Color printing technology uses prisms to separate and combine different wavelengths of light. This allows printers to reproduce a wide range of colors accurately. The precise control of light provided by prisms ensures that printed images are vibrant and true to life. Research laboratories use prisms in a variety of experiments, from studying the properties of new materials to developing advanced optical systems. The ability to manipulate light with precision makes prisms essential tools for scientists and engineers pushing the boundaries of knowledge. In quantum physics, prisms are used to study the behavior of photons and other particles of light. By splitting and analyzing light at the quantum level, scientists can explore the fundamental nature of reality. These experiments are at the cutting edge of modern physics, revealing new insights into the universe. As technology advances, the role of prisms in science continues to grow. New materials and designs are expanding the possibilities for manipulating light. From quantum computing to advanced imaging, prisms will remain at the forefront of innovation, helping us see and understand the world in new ways. We've journeyed through the science of prisms, from their basic structure to their role in cutting-edge technology. Prisms reveal the hidden beauty of light, split it into rainbows, and power everything from cameras to fiber optics. Their study has shaped our understanding of physics and continues to inspire innovation. Whether in nature, art, or science, prisms remind us that even simple objects can unlock the mysteries of the universe. Thank you for joining this exploration of prism physics.